Okay, good afternoon, students. Welcome to elective math class. In this video, we'll be treating partial fraction, the part 2 of it. In the previous video, the part 1, we started by introducing what partial fraction is all about, and I gave an example. Don't forget, I told us there are 4 types of partial fraction. Now, the first one we are dealing with now is the non-repeated linear factor, where the denominator of the given fraction is made up of linear factors, whether 2 or 3 or 4. Now, if you didn't follow my first video, please go back and subscribe and then watch it. So if you miss that video, you'll not be able to understand what we are about to do now. In mathematics, we normally go from simpler to complex. So the first example is a simpler one. It shows you the foundation of this topic, partial fractions. Now let's continue from where we stopped. This is a second example. And this example says that we should resolve this fraction into its partial fractions. I'm going to add the link to my first video in this video so that you can watch it if you haven't watched it. Now, the question says resolve this 2x squared minus 3x plus minus 10 all over x plus 2 into bracket and x squared minus 9 into bracket into partial fractions. The first example and this example has only a slight difference, and that difference is in the denominator. In the first example we did, the denominator consists of 2 linear factors, but in this example, as you can see clearly, the denominator here consists of a linear factor and a quadratic factor. When you see a partial fraction question that contains a quadratic factor in the denominator, the first thing you do is ask yourself, is that quadratic factor factorizable? If yes, then factorize it into 2 linear factors before you start your work. But if the quadratic factor is not factorizable, that will take us to the second type of linear factor, which we are not treating now yet. Now, since we are dealing with the first type, it means this quadratic factor must be factorizable. So I'm going to factorize this into 2 linear factors. In mathematics, there is something called difference of 2 squares. Difference of 2 squares, where I have 2 squares and I'm subtracting them. Difference of 2 squares. If I have something like this, how do I factorize them? The principle here states that if I have difference of 2 squares, take the 2 variables x and a, subtract them, and then also add them up. With this, I have factorized this quadratic expression, x squared minus a squared, x minus a into bracket x plus a. If you expand this bracket, I bet you will get this. Now, we will apply this knowledge of difference of 2 squared to this quadratic factor here. Here we have x squared minus 9. Now you might ask me, there is no square here, so how do I apply this knowledge here? Can I turn 9 into a number with square? Yes. What's that number? 3 squares. There are 3 squared. That is the only way I can factorize this. So x minus 9 will give me x squared minus 3 squared, because 3 squared is 9. Now apply this principle here. This will give me x minus 3 into bracket x plus 3. Any of them can come first. It doesn't matter. So if I expand this, I will get this. Are we together? So now, this is the factorization of this. So I'm going to put this now in place of this factor. That will give me 2x squared minus 3x minus 10 over x plus 2 into bracket, x minus 3 into bracket, x plus 3. You must acquaint yourself with how to factorize quadratic expressions because they come in different forms. So you must know which method to apply when factorizing quadratic expressions. So now, having done this, I cannot continue with this. If I continue with this, I won't get nowhere. So I have to factorize this by quadratic factor, which I have done. Now I'm going to use this as my compound fraction. So bring this on the next line. This will give us 2x squared minus 3x minus 10, everything over x plus 2 into bracket, x minus 3 into bracket, x plus 3. Now from the first example, I told us that the number of partial fractions you are going to obtain from a single compound fraction is determined by the number of linear factors in the denominator. If I have 2 linear factors, I will have 2 separate partial fractions for that compound fraction. If I have 3 linear factors, I will have 3 separate partial fractions for that particular compound fraction. Now, each of these linear factors in the denominator will be the denominator of each of the partial fractions. So for the first partial fractions, my a becomes the numerator over x plus 2, then plus, we are summing them, we always sum them. My second is going to be b as my numerator over x minus 3, the second factor here. Then my third partial fraction will be c over x plus 3. The only thing I need to find are the numerators. I don't know them, so I use alphabets to represent them, capital letters A, B, and C. Don't forget, I said the linear factors in the denominator will form the denominators of each of your partial fractions. Then find the numerators. Now let's find A, B, and C. To find A, B, and C, I'm going to clear off this denominator. I want to remove all the denominators. Just make it a straight equation with no denominators. To do that, I will multiply through by this denominator, x plus 2, x minus 3, x plus 3. Multiply through means multiply this, multiply this, multiply this, multiply this by this. So I state it out, multiply through by x plus 2, x minus 3, x plus 3, multiply through. So multiply this by this, that will give me 2x squared minus 3x minus 10 over x plus 2, x minus 3, x plus 3 times, multiply, x plus 2, x minus 3, x plus 3, everything over 1, equals, also multiply this by this, we are multiplying through a over x plus 2 times x plus 2, x minus 3, x plus 3, everything over 1, plus, also multiplying b by that, b over x minus 3 times x plus 2, x minus 3, x plus 3, everything over 1, plus c over x plus 3 times over 1. Okay, let's clear off the denominators now. From this, you see that this denominator is the same as this, so they will cancel out each other. Now, these will cancel out these completely, leaving only the numerator here. So I will write this now. So I'm going to have left here 2x squared minus 3x plus 10 minus 10 equals, I have cleared off the denominator here. Then this one now, if you watch, you'll find out that these two are the same. So this will eliminate this, leaving only a times x minus 3, x plus 3. So we write that out. A into bracket, x minus 3, x plus 3, plus b now. For b, you'll find out that x minus 3 and these are the same. So they will cancel out each other. X minus 3 cancels x minus 3, leaving x plus 2, x plus 3. So we have b into bracket, x plus 2, x plus 3. Then now see the last under this. X plus 3 here and x plus 3 here are the same. They will cancel each other out. So this cancels this, leaving c into bracket, x plus 2, x minus 3. So we have x plus 2, x minus 3. We have eliminated the denominators. Now we have a straight equation. Let's go. We want to find a, b, and c. Like I said in the first video, there are two ways of finding this. I gave us the first method in the first video, and I said I will give the second method. But I still want to go with the first method. It is cheaper, so I will understand it very well. I will teach you the second method later. We call that equating coefficients. It's a bit complicated, but simple. So let me still maintain the method 1, which I used in the first video. Now let's begin with A. Let's find A. To find A, I need to eliminate B and C. So I have only A left, and I can find A. If B and C are still here, I cannot find anyone. I must eliminate 2, leave 1, and find that one. Now, how do I eliminate B and C? To eliminate B and C, I need to make one of these two zeros, because if I multiply everything by 0, I will have 0. Also make one of these two factors 0, so that everything will give me 0. Now, if you watch, among these 3 factors we have in the denominator, the only one that A here does not contain is x plus 2, while B and C contain it. So if I can make x plus 2 0, I will eliminate B and C. Now the question is, what value should I put for x here that will make this 0? If you check very well, it's minus 2. You don't know how to get it? Check my first video. Find the 0 of this, you will get minus 2. So to find A, I will say let x be equal to minus 2. Since there is no minus 2 for A here, and that is x plus 2, I can use that to eliminate these 2 and leave my A, so I can find my A. Now it means, in this equation, anywhere I see x, I put what? Minus 2. Now let's continue. For 2 here, x is minus 2 squared, minus, where I see x, I put minus 2, minus 10, equals A into bracket x here becomes minus 2 minus 3, x becomes minus 2 plus 3, then plus B, x becomes minus 2 plus 2, x becomes minus 2 plus 3, then plus C, x becomes minus 2 plus 2, let me continue from here, plus C, x becomes minus 2 plus 2, x becomes minus 2 minus 3. Okay, let's expand now. Minus 2 raised to power 2 is simply minus 2 times minus 2, which is 4. Minus 2 times minus 4, then 4 times 2 is 8. Then minus 3 times minus 2 is plus 6. And then minus 10 equals a here into bracket. Minus 2 minus 3 is minus 5. Then here is minus 2 plus 3 is 1 plus b. Now minus 2 plus 2, 0, which is what I'm trying to achieve. To eliminate b, I must have 0 as one of the factors. So 0 here, then minus 2 plus 3 is 1, and then c, minus 2 plus 2 is also 0. Then minus 2 minus 3 is minus 5. So 8 plus 6 is 14, minus 10 we have 4. Then here, minus 5 times 1 is minus 5. Times a, we have minus 5a. So a times minus 5 is minus 5a, times 1 still minus 5a. Then plus 0 times 1 is 0, times b is 0. 0 times this is 0, times c is also 0. So we have succeeded in eliminating b and c, leaving a. We can find a. Now, if you add up all this, we have 4 equals minus 5a. Can we find a now? Yes. How? Dividing both sides by the coefficient of a, which is what? Minus 5. Divide both sides by this minus 5. Now we give it 4 over minus 5, divide both sides by minus 5, equals minus 5a over minus 5. Minus 5 cancels minus 5, leaving only a, that will give us minus 4 over 5. Because plus divided by minus is minus 4 over 5. This is the value of our a, minus 4 over 5. Now let's find b. The same thing we did here for a, we do for b. Find a way to eliminate a and c, leaving only b. Let me rub this side off. Now be thinking what value x can take that will enable us to eliminate a and c. Be thinking on that before, while I rub off the board. I trust by now you must have gotten that value. Okay, let's find b. To find b, let x be what? Now, if you check our 3 denominator, the factors there, the only one that b does not contain, which a and c contain, is x minus 3. So if I can find a value for x that will make this 0, I can eliminate a and c. That value is what? 3. So that 3 minus 3 will give me 0. So I will say let x equals 3 here. Are we together? That's good. So anywhere I see x in this my equation, I put 3. So this will give me 2 into bracket 3 squared minus 3 into bracket 3 minus 10 equals a into brackets 3 minus 3 into brackets 3 plus 3, then b into brackets 3 plus 2 into brackets 3 plus 3, and then plus c into brackets 3 plus 2, and then 3 minus 3. Now let's expand the brackets we have there. 3 power 2 is simply 9. 9 times 2, 18. Minus 3 times 3 is minus 9, and then minus 10 equals our a into bracket 3 minus 3 is 0, which is what I'm trying to achieve. And then 3 plus 3 is 6 plus b 3 plus 2 is 5, and then 3 plus 3 is 6, plus C, 3 plus 2 is 5, and then 3 minus 3 is 0, which is my aim of making x 3, to make the 0. So 18 minus 9 is 7, is it 7? Okay, 9 minus 3 is minus 1, equals 0 times 6 is 0, times A, 0, plus 5 times 6, 30, times B, 30B, plus everything here will give me 0. Now this will give me minus A equals 30B. Then want to find B. Divide both sides by 30. If we do that, our B is going to be minus 1 over 30. That's our B. So we have found B. Now finally, let's find C. Do the same thing there. Which of those three linear factors in the denominator? That A contains, B contains, but C does not contain. If you check, it is what? X plus 3. There is no x plus 3 here, but B has x plus 3, C has x plus 3. So if I can find a value for x, I will make here 0 and go to go. What's that value? Minus 3. So I will say to find C, let x equal minus 3. So in this my equation, anywhere I find x, I put minus 3. Let me continue from down here. So this will give us 2 into brackets minus 3 squared minus 3 into bracket minus 3 minus 10 equals A into bracket minus 3 minus 3 minus 3 plus 3 minus 3 minus 3 minus 3 plus 3 plus B into bracket minus 3 plus 2 minus 3 minus 3 minus 3 plus 2 minus 3 plus 3, and the C will give us into bracket minus 3 plus 2 minus 3 minus 3 minus 3 plus 2 minus 3 minus 3. Now let's expand the brackets. Rub it off. Okay, now let's expand our brackets. Minus 3 squared simply means minus 3 times minus 3, that will give us plus 9. Then times 2, 18. So here we have 18. Minus 3 times minus 3. This times will give us plus 3 times 3, 9. So we have plus 9. And then minus 10 equals A into bracket. Minus 3 is minus 6. Minus 3 plus 3 is 0. B into bracket. Minus 3 plus 2 is minus 1. Minus 3 plus 3 is 0. C into bracket. Minus 3 plus 2 is minus 1. And then minus 3 is minus 6. Okay, now let's simplify. 18 plus 9 is 27. Minus 10 is 17. Minus 6 times 0 is 0. 0 times A is 0. Minus 1 times 0 is 0. 0 times B is 0. Minus 1 times minus 6 is plus 6 times C is 6C. So simplify for that, we have 7 equals 17 equals, everything will give me 6C. Now to find C, we divide both sides by this 6. We have C equals 17 over 6. Now, we have succeeded in finding the values of our numerators, A, B, and C. What's my A again? My A, okay, let me put them somewhere here. Our A, we got minus 4 over 5. B, we got minus 1 over 30. And C we got 17 over 6. Now, substitute this value into our previous equation. We have 2x squared minus 3x minus 10 over our original compound fraction was this, x plus 2 into bracket x squared minus 9. This is what we are asked to resolve into partial fraction. So your final answer must contain this. Equals, the first fraction contains a over x plus 2. What's my a now? Minus 4 over 5. So I have minus 4 over 5 over x plus 2. Plus, second one is b. What's my b? Minus 1 over 30 over x minus 3. Third one is c. My c is 17 over 6 over x plus 3. Can I stop here? No, sir. This is mathematically wrong. So I have to work on this. In mathematics, you can't have a fraction like this. Minus 4 over 5 over x plus 2. Doesn't make sense. It should be this over this. Numerator and denominator. Numerator, yeah, I have how many numerators? I can't even tell. So let me simplify this now. In simplifying this, I will have minus 4 over, bring this 5 down. And the 5 will multiply everything here. So open a bracket, x plus 2. Simple fraction. Do the same thing here. Plus times minus is minus 1 over, bring us 30 down, 30 into bracket x minus 3 for the second fraction, then plus 17 over, bring us 6 down, 6 over x plus 3. My final answer. If you stop here, you are correct. But for me, I will stop here. I don't like a negative value to always begin my expression if I have a positive value in the expression. So I will bring this one first. Anyone can come first, it doesn't change anything. So bring this one first. I'm going to have, therefore, 2x squared minus 3x minus 10 over x plus 2 into bracket x squared minus 9 will give me 17 over 6 into bracket x plus 3 minus 4 over 5 into bracket x plus 2 minus 1 over 30 into bracket x minus 3. Well represented. Final answer. To check if you are correct, if you add up these three fractions the way they are, it will give you the single compound fraction. With this, we have come to the end of the first type of partial fraction, which is non-repeated linear factors in the denominator. Watch out for part 3. Here we'll treat the second type, non-repeated, non-factorizable factors. You need that. It's very important. For now, thank you. See you.